Welcome. In this module, I will talk about European ambitions related to offshore wind energy. As part of the European Green Deal, EU aims for a carbon-neutral power supply within 2050. To achieve this goal, wind energy plays a major role. One of the reasons is the vast offshore wind resources available. The available offshore wind resources in Europe are illustrated on this map. To the left, you see a wind map covering the offshore waters of Europe. The lighter the color, the higher is the average wind velocity. The map is made from data in the period 2010 until 2020 and refers to 100 meters above the sea level. As will be discussed in more detail later, the energy content in the wind is proportional to the third power of the wind speed, meaning that increasing the wind speed from 8 to 10 meters per second implies an almost doubling of the available energy. Considering the areas close to shore, less than 60 kilometers from the shoreline, the International Energy Agency, IEA, estimates the yearly energy potential of offshore wind to be about 15,000 terawatts-hour, while in the areas 60 to 300 kilometers from the shoreline, the estimate is 45,000 terawatts-hour per year. These numbers are to be compared to the electrical power consumption in EU in 2019, amounting to less than 3,000 terawatts-hour. This is illustrated by the gray area to the right. The offshore wind resource could thus cover the European needs several times. Now, such energy potentials always should be used with care. We may start out with the geophysical potential, considering the wind over a certain ocean area. Technology will limit the availability of these resources, but technology is developing over time, and so is the technical available resources. For example, some years ago, offshore wind turbines at water depth beyond 30 to 40 meters were not considered technical or economical feasible. By introducing floating support structures, water depth of several hundred meters may be utilized. But even if a potential wind farm location may be feasible from a technical and economical perspective, social, political, and environmental consideration may cause the areas to be excluded. Areas to be excluded may be such as protected area, spawning areas, important fishing areas, bird migration routes, military training areas, important fishing routes, visibility from shore, etc. You should therefore always check the criteria used when the energy potentials are presented. The real, usable resources are always significantly smaller than the geophysical or technical resources. We will now consider the status and plans for offshore wind development in different regions globally. It is observed that Europe presently is in the lead and has the most ambitious plans for the next couple of decades. These numbers were presented prior to the Russian attack upon Ukraine. After that, energy supply security and reduced dependency upon imported gas have entered the energy agenda. EU will now speed up the introduction of renewable energy, in particular wind and solar energy. In North America, the operational offshore wind capacity is very small. The only operational wind farm by 2021 is the Rhode Island wind farm with 42 megawatt installed capacity. Ambitions for 30 gigawatt in 2030 are presented and more than 100 gigawatt in 2050. a modest ambition compared to Europe. Asia, in particular China, has started an offshore wind adventure, but they are still behind Europe. The development speed is, however, high, and it is expected that the installed capacity by 2030 will be of similar magnitude as in Europe. Presently, however, more modest aims are presented for 2050. Globally, it is observed that to reach the 2050 goals, we on average need to install in the order of 30 gigawatt offshore wind capacity every year for the coming 20 years. 30 gigawatt is about the same as the accumulated capacity by last year. The task at hand involves thus a huge industrial upscaling, which will challenge the complete supply chain and the educational system. It will also require functional laws and regulation that can balance all interests involved, including the environmental perspectives. Based upon the above considerations, let us look at how large ocean areas the planned developments involve. We may start with the size of the Norwegian exclusive economic zone and the area of the North Sea, as they are defined on the two maps to the right. The areas are almost 800,000 square kilometers and almost 600,000 square kilometers respectively. How much ocean area will the 400 gigawatt ambition for Europe require? First, we note that 400 gigawatt installed capacity will produce close to 1,800 terawatts-hour per year, or about 12 times the present yearly energy production from the Norwegian hydropower system. How dense you may place the wind turbines in a wind farm depends upon several factors. We will come back to some of those later on. But we may assume an installed capacity in the range 5 to 7 megawatt per square kilometer as typical. This corresponds to a 6 to 8 rotor diameter distance between the turbines if they are placed in a rectangular pattern. Using as an example 6 megawatt per square kilometers, we see that an area corresponding to in the order of 10% of either the Norwegian economic zone or the North Sea is needed for the wind farms. It is also observed that less than 1% of the Norwegian exclusive economic zone is needed to produce a yearly energy amount equal to the Norwegian hydropower production or to the 2040 ambition of 20 gigawatt offshore wind power.